Hello, everyone. My name's Taj, and today I'm going to be presenting for the AI Horizon Conference on the topic of exploring new frontiers, unleashing generative AI in space technologies. First and foremost, I want to thank everyone for their time to really watch this presentation, listen to it, and especially want to thank AI Horizons for giving me the opportunity to present on this topic. I'm a huge space nerd. I'm very passionate about this topic, and my intent today is to really bring to attention how generative AI is not just being applied to terrestrial applications or technologies, but space technologies as well, and kind of envisioning where it's going to go in that aspect, and how it's going to really change a lot of things for space, and in return change things for technologies on Earth as well. So I'll start off with a brief introduction of myself, and we'll go into an overview of what I'm going to be going over today, specifically generative AI in space technologies, and a large plethora of the presentation itself will include various technologies that are going to be affected or will utilize generative AI, be it text, video, and large language learning models themselves, and how those will be applied to those technologies. And we'll kind of briefly go into what I kind of envision will happen in the next 5 years, which is a pretty short time frame, but we'll talk about that, and we'll conclude our presentation here. So without further ado, my introduction here is I'm Taj. I really got into space exploration when I was very little, and I was a huge sci-fi movie fanatic. I love Battlestar Galactica, Stargate SG-1, Star Trek. I was really passionate about that. When I was a kid, I used to build those model rockets and launch them in my backyard. One of my biggest passions, and still my goal today, is to go to space one day. And I will go to space. And I remember when I was studying at Embry-Riddle Aeronautical University, I was studying aerospace engineering. I got to see the last two space shuttle launches from the NASA space shuttle program, and it was the very last two, and I got to see them in person, and it was probably the most fascinating, phenomenal thing in the world. It was unbelievable just to witness that raw power of a rocket escaping Earth's gravity. It was pretty fascinating, and I had the wonderful opportunity to also do research under a NASA space grant on the trapezium star cluster, otherwise known as the Orion Nebula. And many may know the Orion constellation in the night sky. So this is the Orion Nebula, actually, and I specifically on this research team at West Chester University studied the Theta 2 Ori star here, which is a binary star system. So it's a pretty cool, pretty large star. It's about, I think, 500 light years away, approximately, pretty far away. But it was really cool, and I got to work with telescope data, and we'll kind of get into a little bit how generative AI is going to affect for the better observational data and simulated data as well in the presentation. So generative AI in space. I think we're going to start a little bit closer to home here, a little bit closer. Satellites, they're in high Earth orbit. Most of them are in high Earth orbit. And we're going to talk about how generative AI is kind of going to really touch on satellite technologies, and specifically around imagery. So we know telescopes like to look out into space, but we have a lot of satellites that actually do a lot of observations of Earth on the surface of Earth, which is really critical to understanding specific weather patterns, climate data, and even also for, in the defense industry as well. It's used to monitor specific movements and troop data, things of that nature. Now, the resolution of these satellites is pretty phenomenal. And it's only getting better. And with the applications of generative AI, they can get significantly more enhanced as well. I mean, we've already seen examples of generative AI enhancing or upscaling video quality or image qualities. Now imagine that being applied, and it probably already is to this day, already being applied to enhancing satellite image data. One thing to keep in mind with generative AI is that they're prediction machines, right? So we're creating statistical predictions on what a specific parameter could be, or what a specific piece of data could be, in this sense. So what I mean by that in regards to satellite imagery, and any kind of image enhancement, or any kind of video enhancement or creation, we're predicting what it could be, the most optimal output based on a text input or based on an image input or video input. So if I have observational data from a satellite, I can create inferences or glean what might happen based on patterns, detect changes, things of that nature. As long as I have a solid foundational model or a baseline to compare it to, I can actually infer and create a very accurate prediction. So we're going to see a lot of these softwares being applied, or a lot of these generative AI applications be applied to the software that's included in these satellite imageries or satellite imagery technologies that will actually help detect changes. And like I think on the slide, I mentioned how it's going to be able to monitor specific changes in climate, and disaster tracking. So one specific analogy here would be, imagine, for example, and a lot of this still happens or does happen currently. So I think it's interesting to think about where it's going to go too. So back to my point, imagine, for example, a satellite detects a mid-latitude cyclone being formed off the coast of Africa, or in other words, a hurricane. And if you're in the Pacific, it's a typhoon. Imagine if it detects that there's a large probability of it being formed. It creates a prediction of where it's going to go as it gets closer and closer. The predictions get more accurate. Now, with the satellite data, if we have a solid understanding of, perhaps 80% or greater chance of this hurricane hitting this specific city or this specific landmass, excuse me, and we can then connect that satellite data automatically to first responders, supply chain. We can actually have systems in place where it's automatically preparing itself, from a software standpoint, where we have systems that are actually in place detecting, okay, we're going to have an impact in 4 days or 3 days, and we need to have these assets in place. We need to have these first responders in place. So it kind of piggybacks off each other, and we get this really robust system that is really run by a generative AI. So let's move on to another piece. I'm sorry if that picture is not showing up. Doesn't look like, but it's actually, I'll describe what the picture is in a second. Excuse me. Automating spacecraft diagnostics. So this is another cool feature that I think we're going to see. And we actually already have a lot of that tech currently today. SpaceX has been implementing a lot of this stuff within its Dragon capsule as well. I'll go into that a little bit. One of the things where generative AI can really shine when it comes to space exploration or spacecraft diagnostics is having predictions of when parts might go bad, running diagnostic tests, continually running diagnostic tests in the background. So as opposed to having a crew running these tests, you're now having the AI take over and understand that, okay, this specific part needs to be replaced, or this specific piece on the spacecraft needs to be modified. Furthermore, we could even have 3D printers on the spacecraft that will print the part automatically when it needs to be replaced. One other cool feature that it could be applied to is collision avoidance, advanced astrodynamics. And what I mean by that is, I'm sure if anyone hasn't seen the movie, there's a lot of sci-fi movies that depict spacecraft en route to their destination, and there's, a meteor band, or there's asteroids in the way, so to speak. And space is very big. And that being said, there are debris that are out there that could, impact the spacecraft. If you have these advanced warning systems that are on spacecraft, you can have the AI or the onboard AI, generative AI, actually detect, and calculate the paths of these potential projectiles and create avoidance maneuvers, right? Maneuvering in space is very different than maneuvering, a fighter jet or a plane in the atmosphere. There's no up or down in space. So being able to actually maneuver and avoid specific obstacles is very critical. And while also maintaining your trajectory to your destination. So that's where astrodynamics comes into play, orbital insertions, and various maneuvers in that sense. Simulations and automated maintenance. I think I kind of touched briefly on that as well, where this, the AI can actually run simulations of specific maneuvers as well in specific scenarios. The best way to kind of figure out the best path of least resistance is to simulate all the paths. And if they all end up with failure, if there's one that ends up with a success, the AI on board will suggest, okay, this is the best option. So this picture was actually depicting HAL 9000, which is from the movie 2001 Space Odyssey. And for those who don't know, the famous quote, "I'm sorry, Dave, I'm afraid I can't do that." And the kind of the premise from that is, in this movie, the AI on the spacecraft was tasked and hardwired and coded with two contradictory parameters. One being so the mission for the astronauts was to go to this planet and find what's called the monolith. However, two of the mission parameters, one of them being, okay, bring the astronauts to the monolith. And the other one was that the astronauts cannot know the secret of the monolith because of national security. So the contradictions that caused the AI to actually kill the crew and take the crew to the monolith because it accomplished both parameters. It brought them to the monolith and they don't know the secret of the monolith. So there are a lot of scary things with AI that could happen. So we have to be very careful with how we kind of, we don't want to create contradictions in its coding, things of that nature. And there are ways around that. And but that was a great depiction of, or I should say, bad depiction of just how AI could be a bad AI in that sense. And we want to create a really truthful AI. Moving on, so autonomous space exploration. This is another really cool topic. And when I created this image, it kind of reminded me of Wall-E in the corner there. Autonomous space exploration. This is kind of going to be, so if you think about it, think about how we have drones right now on the surface of Mars. We have NASA's actually has a flying drone on Mars. If those of you that do not know, it's flown quite often actually. If we have these systems in place where they're conducting their own experiments on Mars, relaying that information back to a satellite, which then relays it back to another system on Earth, these future systems are not only going to be able to do their own experiments, but they can actually make their own decisions as well. So we can have a decision tree, an automated decision tree in place where it's conducting experiments. It takes the results of those experiments and then deduces that, okay, it generates its own hypothesis based on the information that it learned, right? And over time, as it learns further, it will conduct more experimentations and analyses to determine the answer to that hypothesis. So a lot of these systems are going to be able to do that. So it'll be very interesting to see a fully automated, space drones and rovers going out there rather than sending humans all the way out into space, light years or millions and millions of miles or multiple AU astronomical units away from Earth in danger. We can send these drones and rovers first, right? Now, I don't want to suggest that humans will never go out into space. I think it's our main prerogative. I think it's part of our nature really to really explore and to go into the unknown. From the very beginning of like explorers crossing the ocean, that was a big deal that, that we had to do it. It was part of our nature to go into the unknown. And I think we'll continue to do that. I think we're going to be working hand in hand with these autonomous systems and not necessarily leave it to just them to figure it out. Another great aspect of technology here is the mining and spectral analysis. You'll be able to have these drones automatically, even satellites, using AI and satellite imagery as well to determine which sites will be the most optimal for mining. We could even run tests on the soil, either from a laser in space, from a satellite, or from a drone on the surface, and determine what the contents are of that specific area of the minerals there, and is it usable? How can it be used? Can we make some cool 3D printable material out of it? If we just put a 3D printer there, we could just 3D print stuff for our habitat. Another great thing is we can run we could actually conduct external observations from that planet. So we could have these systems act as miniature telescopes and observational posts, essentially conducting spectral analysis of other stars, right? Their atmosphere is a lot thinner, so we'll actually be able to get a much higher resolution and less interference, right, from the Earth's atmosphere from these telescopes or these rovers equipped with observational technologies as well. Moving on to designing new spacecraft. So this one's a cool thing where we can actually have these. So for example, imagine having, like I mentioned before, a 3D printer on a spacecraft, and you're en route to your destination, and the crew comes to find out that there's a specific nozzle or specific rocket component on their ship that has gone, it's not operating efficiently enough. Well, we can't go back and we can't have them mail us a new rocket nozzle. So our onboard 3D printer is going to print out a new rocket nozzle for us, and we're going to get it replaced. That type of stuff is happening now. There's a company called, I believe it's called Relativity. Um, Someone can correct me if I'm wrong there, but this robot is a robot arm that actually can 3D print entire rocket columns. So this is actually currently happening today. And they are, I think, going to be making a maiden flight at some point, either this year or next year. I'm not too sure, but the fact that they're able to print solid rocket columns from the ground up is unbelievable. And this kind of gives to how this type of technology is evolving, and now just incorporating generative AI in that aspect, we can actually include new designs, new design features, new variables and variations. We can also simulate, right, how this nozzle is going to operate in specific altitudes or in specific gravity wells, for example, of large mass body objects in space. We can upgrade engine parts, en route, essentially. Let's say there's we've done some more research on Earth, excuse me, and we've discovered that this specific rocket nozzle actually performs a lot better with this piece on it or in this design configuration, rather than the spacecraft. Rather than waiting for the next iteration or next mission, we could just send the part to the spacecraft that's en route, send it to them. They'll print it on their spacecraft and they'll swap it out and they'll upgrade their engine. That's a pretty cool feature there, and I think that's going to start happening a lot sooner than we think. And moving on here, so this is actually a rocket nozzle that was designed by an AI using vast amount of data from a computer-assisted drawing algorithm. And it was specifically, so this specific rocket nozzle is called the hyperganic EOS rocket nozzle. It's currently being tested. And one of the coolest things is that it was designed in minutes, printed via SLS 3D printing in days. And it was also designed beyond the human imagination or capabilities. I think that's a really cool feature to think about and imagine, is that this technology is allowing us, and when we use it hand in hand, in a hybrid way, it actually assists us to widen our imagination. Like we couldn't, aerospace engineers couldn't really have just come up with this type of design on the fly in minutes. But with the help of generative AI, it did, and it got printed out, and they're testing this engine, and who knows, maybe it won't be effective or efficient, but we through failure, we learn how to actually optimize these systems, and we can continue to fail and fail fast, and we succeed eventually. Generative AI in space, enhancing astronaut training. So this is a big one for me too. I think this is going to be really revolutionary in this aspect of training astronauts. We can create realistic simulations in augmented reality or mixed reality. I don't know if anyone has seen, but Disney's recently released an omnidirectional treadmill where you can actually run or walk on, in place and in a virtual environment. So a lot of these different things can be tailored to simulate extravehicular activities, or even walking on the moon or walking on Mars. and other planets as well. It's going to be very game changing there. We can have unexpected challenge simulations. We can have, currently we have these training modules that are hard coded that humans created, right? Well, we could have our generative AI throw in some real interesting events that we wouldn't even have thought of. And how do humans respond to that? How do astronauts that are highly trained to respond to those types of intense situations? I think not only will we get a vast amount of amazing data from those training simulations, just based on human psyche and astronaut psyche at that point. But we'll also understand how they respond, and we'll prepare our future astronauts for these crazy events that might happen. And no one's to say they're impossible. Anything could happen. I think a perfect example of this is actually a Star Trek reference here. The Kobayashi Maru, which is a computer simulation used to train the Starfleet Command crew. And it was actually created as a no-win scenario. There was no way to win this specific simulation, which is very interesting because they wanted to actually see how the crew would respond to a no-win situation. And it's very intriguing in that sense. Another piece where this is actually has been shown in a movie, actually, Ad Astra. If you recall, if anyone's watched that movie, the astronaut played by Brad Pitt he takes a psych exam talking to an AI essentially, and the AI is able to determine his emotional focus, his specific parameters in his voice, his tension, right before the missions. And based on these specific parameters, it's either a pass or fail. If he's ready to go on this mission, or is he too stressed out? Is his tension too high? So these things are being applied today too. We're seeing that a lot terrestrially, with a lot of generative AI being used in the mental health space. And we're going to see a lot of that be applied to these types of training situations as well. Another big one is an astronaut companion. We all see these in the movies where we have this AI that is assisting the human astronauts or the human crew along their journey. But the one thing they don't really show is a companion, right? Is someone that's actually there for them. And we're going to see a lot of, I think that's going to be very critical, because of those of you that may or may not know, it's pretty psychologically burdensome to be in a small capsule for over a year, essentially, traveling to your destination at subliminal speeds or slower than light speeds. And it's going to take a long time. You're away from home. There's a huge psychological burden there. Now, if we create an AI that's human-like in nature and can be a companion to these astronauts, it could really be a game changer for these astronauts' psyche. So moving on. So the next 5 years, I think, so 5 years happen. 5 years is actually not that long. So I kind of wanted to, I thought about this, and I kind of wanted to envision or be a visionary here and talk about where generative AI specifically, is going to be in the next 5 years for space. AI will further be integrated into spacecraft systems. We actually already see a lot of that today with SpaceX's Dragon capsule. Those of you who may not know, the Dragon capsule actually has an onboard automated escape system. So, for example, during a launch sequence, the astronauts are on board. If specific parameters are not reached, or there's a failure that occurs, it automatically will allow the astronauts to escape in a capsule, and it sends them away from the spacecraft, which is pretty ingenious. It's very, very complex. Those types of systems are not easy to build or create, and it really goes to show the level of effort and ingenuity that's been put into place here. And it's only going to get smarter. It's only going to get more advanced. I want to also point out that a lot of these advancements, I hear a lot of people say, oh, why are we putting money in development into space? And why are we doing this? A lot of people don't realize is a lot of our research and development that occurs from space funding or funding in exploration in this sense actually translate to technological advancements on Earth too. Your phone is a great example, or is a great example of this as well. Nylon, a lot of the fabrics that we see today are actually a result of funding from research in space exploration. Velcro came from NASA, believe it or not. So AI will also play a pivotal role in identifying, analyzing, and utilizing space resources such as water, ice on the moon, or minerals on asteroids. That's going to be great. I think it's going to be, you're going to have these satellite systems that are going to be able to determine, or even telescope systems where you're going to actually take a look at observational data and be able to determine statistically the likelihood of having specific minerals in specific regions, which will further enhance our ability to really land where we need to land on a specific planet, moon, asteroid, things of that nature. Even terrestrially on Earth, we'll have these satellites be able to look back and have generative AI predict where the most optimal place is to land, for example. So we're also going to significantly advance the autonomy of space missions. We're going to enable spacecraft, rovers, and drones to operate with minimal human intervention. So rather than having these giant crews on Earth monitoring these rovers or these satellite systems at launch facilities or at mission control facilities, they're going to be more automated in that sense. They're going to be able to correct their own orbits. They're going to be able to correct their own systems, self-healing systems. Those are all going to, I think, be on the cusp in the next 5 years. Oh. So my call to action here, my intent was to kind of drive your imagination and where generative AI is going to go, not just from a text-based thing, because a lot of people who think about generative AI, they think about ChatGPT and image generation and video generation, but it's much further. It's much more impactful than that. And I really want to drive that idea of being engaged and informed on these latest AI developments, because they won't only impact space and other areas of technology, but they'll affect terrestrial technologies and development as well. The other aspect here is I really want to inspire and drive innovation for the next generation. I think it's important for our youth to understand where this technology is headed, not next year, not 2 years from now, not even 5 years from now, 10 years from now. Where is it going to be? How is it going to affect our society and our civilization in the next 10 years? It's important to think ahead of where we are going to be and plan for the future. It's easy to develop a product for today based on technology today, but by the time you're finished developing it, that technology is obsolete. So, I think it's very important for us to stay informed on all the different areas of how AI is going to be affecting specific areas here. So I want to thank everyone very much for listening. I'm not sure if we have time for questions or comments, but feel free. I think this will be posted on YouTube, so feel free to ask them in the comments there, in the comment section, or also reach out to me on LinkedIn. I have a hobby podcast, Tachyon Talks. I talk about a lot of nerdy stuff there. Generative AI, I talk about a lot of different tech stuff. I interview a lot of people. So if you'd like to come onto my show and have a conversation about some cool tech stuff, let's do it. I mean, reach out to me on LinkedIn. My websites are there for 3D printing and AI consulting as well. So thank you very much, and I appreciate everyone's time.
Thank you, Taj. I have a couple of questions for you.
Sure.
Can you hear me?
Yes, I can.
Okay, perfect. So I was wondering if you could tell us a little bit about mining in space.
Sure. Yeah, so it's no easy feat. Let's just say that. And I'm sure a lot of people have seen a lot of headlines of, these asteroids that they discover, or even comets in general, but asteroids that they discover that have more resources on them than the entire economy of the world. And if we land a resource mining rover on these asteroids, what would it do to the world economy? It's very interesting to think about it in that sense and the domino effects that will occur. That being said, it's easier said than done. It's not necessarily hard, but there have been missions. I believe Japan actually launched one where they successfully landed on these asteroids. So, and I believe NASA as well. So, and private industry is actually exploring right now on how to do it. How do you capture these small little asteroids? How do you keep them in place? There's a lot of pieces, a lot of moving pieces. It's not easy, like I said. But that being said, yeah, capturing, you have to capture the asteroid, and then you have to figure out how to get equipment on there, extract the resources. I'm pretty sure you're not going to refine them on site, so you'd want to extract the raw resources and then have it be delivered back to Earth to be refined. Or maybe in the future, you'll have refineries that are located in high Earth orbit or a Lagrangian point in space, and it's refined there, and they send back the actual product back to Earth.
Great. And then my last question is just about 3D printing. So I was wondering, where are we with 3D printing and 3D printing in space? And what materials can we currently print with, and which materials are we doing research and development on at the moment?
Sure. Yeah, so 3D printing in space has actually been around for a while, believe it or not. They have one on the International Space Station currently. I don't recall which university actually developed the technology through research, but there was a lot of talk of creating a printer that could operate in zero gravity. And current 3D printing technologies is advancing so fast. We have SLS systems now, so selective laser sintering 3D printers, where they use a high wattage laser to actually melt the beads of materials and solidify it into layers. You could literally print any material in that sense. So nylon 12, titanium, carbon fiber, polycarbonate. There's a variety of different materials you can use. Some materials work better for different methodologies for 3D printing. So you have FDM, fusion deposition manufacturing, SLS, like I mentioned, selective laser sintering. There's a plethora of different methodologies to use. I think it just comes down to efficiency. And, at the end of the day, everything comes down to energy too, because it's going to take a lot of energy to create these things and operate and maintain your printer and AI systems as well in space.
Oh, and last question. So you mentioned a little bit about AI companions in space from a mental health perspective. What about actual healthcare in space?
Sure. That's a great question. I actually personally know of a specific company, a startup company actually out of Canada called Lunar Medical that's been doing a lot of research and development in that space. And they've actually named their system McCoy, which is named after the Star Trek doctor. Their system's pretty interesting. They're actually focused on working on creating delivering this healthcare to astronauts once they're on the moon. And I think that research and development in that area is really going to drive innovation on how it can be applied en route to on a spacecraft or on Mars, and maybe even create better, more functional systems for Earth. If it can work in space, it probably will work a lot better on Earth too, hopefully.
Awesome. And just a silly question, but what is your favorite sci-fi movie in space?
Oh, oh gosh, that's a tough one. But I have to say, 'cause it feels like they come out with like a it feels like they come out with one that just tops the next one after a few years. I back to Interstellar. I love Interstellar.
Yeah.
Kip Thorne, who's the astrophysicist who is actually assisting that movie's development, is phenomenal. If you read his books, he's a famous theoretical physicist. That movie was highly accurate when it comes to astrophysics, and they really use a lot of cool math there in that movie.
Awesome. Well, maybe we should turn your presentation into a movie script and send it off to him. See if this could be his next movie.
Yeah,
But
maybe.
thank you so much. This has
No
been
problem.
absolutely
Thank you very
great and
much.
really enlightening. Okay, well, have a good day.
Thank you. You too.
Bye.